Okay. Probably don't have a ton of this to go over, so I'm anticipating it's probably 15 or 20 minutes of just talking about further optimizations. I did first want to remind people that a week from tomorrow is the event in the Catalyst lobby for the electrical engineering capstone projects that I said that there would be game dev projects for. So if some member of some team can go show off some game, either the first or second game that you made, normally I would say show off the second game, but since the first games were so good, I don't know. We have some good games in development as well. Yeah,
Are we still gonna do our thing on Friday?
yes. Yeah, so there will be two things happening next week. Since we're already in week 9 somehow. The end is nigh. But yeah, we'll both have that event and our big event because I don't anticipate that people will have a ton of time for each individual game. It's more of a here's what we've been focusing on in the Catalyst building. The professional advisory board members have been invited, and there's only going to be one laptop to play games on. They can't spend 20 minutes playing your game and engaging with it. It would more be a show, a little bit of a showcase, some questions back and forth. So the real opportunity for people to play the games will be in the Friday event. And we should also use Wednesday as an opportunity to advertise for that. You want to play this more or see more detail about this or ask more detailed questions? We have an event for that. So I just want to create some engagement with the rest of the Catalyst community, the rest of the campus community. Well, we are not at the main campus. Any questions, thoughts? That's really all that is on the docket, aside from I'll make sure that I get you a study guide by Friday or an exam on the last day. Yeah,
Are we gonna have time to review next week?
yeah, yeah. This is the last bit of content that I have prepared. So the rest of this week we can spend, I want to make sure games are as good as they can be. And since on week 10, the games will have been due, that'll be a good time to review. So our Monday, Tuesday, Wednesday class, we can review for any chunk of those days and or spend some time writing some reviews. I can spend some time reading drafts of reviews to give you some feedback on where I think improvement could be.
Well, Wednesday's canceled. No class on Thursday, so it's gonna be Monday, Tuesday next week.
Yeah, since I did say Monday, Tuesday, Wednesday. Since Wednesday we're doing the event. Yeah, Monday, Tuesday would be our 2 review days. And or if there's any time after that, if there are fewer questions than fills the time, then we can fill it with something else useful. It's quite the attendance.
They're giving away free food downstairs, so.
Never mind, class is canceled.
It was relatively upsetting because I was down there for 20 minutes because I'm like, well, we'll be here in 10, right? They finally were getting the food set up. It was at like 12:55. And then of course by that point there's like a line that's like a mile long. It's like,
Is it going to be still there after class? Or is it going to be out by the time class is over? Who knows? All right. Well, we all know what we're doing immediately after class. Maybe we can even let out a little bit early so that we can go do that. That would give David a chance to drive over here a little early too, if he's not already doing that, since my meeting with him is immediately following this. All right. Last time we were talking about optimizations, we ended talking about rendering path optimization, but I'm just going to go back through everything that we talked about just to recap the optimization concepts, and then I'll launch the slide at the deck at the slide we were on. So we started talking about memory pooling as a solution to inefficient memory allocation. So this allows us to allocate memory in blocks, reducing fragmentation, making sure that we have fast, easy access to all of our necessary memory. But there were some downsides or some drawbacks to that, in that because of the fixed size blocks, if we're allocating just a piece of that, we allocate the entire block. The management overhead for that of when do we reallocate where the blocks are how to allocate those blocks, and then what happens if we run out of memory in the memory pool. Even if there is system memory, we don't necessarily want to be writing to system memory if it's not part of the memory pool. We talked about data structure optimization and didn't go into any detail on that because that's what half of this degree is about. We talked about memory profiling. So being able to look at and profile both your system RAM use, your memory, and your GPU. So how much memory is being used during certain scenes in your game, a way to identify memory leaks, any excessive memory consumption for something that's taking more memory than it should, even if it isn't a leak. And just making sure that sometimes you don't see this problem happening unless you leave a game on overnight. So this is a test you do before you release something. Is just launch the game, set up some auto hotkey script to run around in circles for a bit, making them large circles so that maybe some of the scenes are being allocated, or you're doing some rendering, then de-rendering, and then rendering it again and de-rendering the same system, the same set of assets in an area in your game world, and seeing that at the end of that, the most memory that should have been allocated is that, and not more memory than it takes to render that area of your map. You shouldn't be allocating that memory multiple times. You should be caching and reusing, or yeah, so that's what memory profiling is for. We talked about level of detail systems for drawing your textures at a level of resolution that the player can actually notice and engage with, and not more than that. If player is far away from an asset, there's no need to render it in high detail. There's no way they can possibly engage with it at that level, unless, of course, they have a sniper and are looking through the scope. But when they do that, maybe that's when you render some of those things, or in preparation for them doing that. So there are always considerations on level of detail systems and when you would want to do some of that rendering. When they equip the sniper, you could start to render things in more detail that are a farther distance away. If they don't have that equipped, then there's no way they can engage with that at that level. So those are all kinds of design decisions that you could make. We talked about asynchronous loading of loading assets in the background. This is something that you can always be thinking about in a game, is what is the next asset that the player is likely to need. So you can always be loading something in the background while the player is engaging with the game world, so that you need fewer loading screens. If you do need a loading screen, the time of that loading screen is minimized. It's still loading the same amount of stuff otherwise. It's just intelligently using the system resources so that it doesn't interrupt the player's play flow. We talked about segmentation and prioritization as well, dividing assets into segments so that you load the different segments rather than each individual element. So we will come up with a priority list for the different segments. And as the player acts in the game world, you will be consistently reprioritizing and resegmenting your assets in ways that create easy load times. Then last one we talked about was rendering path optimization. So the number of draw calls, optimizing the scene graph. So as you may or may not know, the scene is split into a graph. And then how the scene is rendered, it's based on the draw calls of that graph. So we would use culling techniques here to avoid rendering objects the player cannot see. This is the idea of, again, there's a wall between the player and the asset. The actual distance in the game world between the player and the asset is large, even if the cardinal distance as the crow flies, if the crow could also fly through walls, would not be very high. So you can use the actual game world distance between player and object to decide what to render and when. And that way you're not rendering things the player either is not going to see or is not going to see for a long time, based on, if they're inside of a building, they have to exit the building to see what's outside the building unless there are windows. We talked about, I think we were on rendering path optimization. So we can start out talking about dynamic resolution scaling. This is something that, have people played games that have dynamic resolution scaling?
What is that again?
Where resolution changes on the fly?
Oh, yeah, I think so, yeah.
So this was added, the only game that I've played that's had it was Path of Exile. They added it within the last few years. I call that relatively recent because I'm old and do things other than play games. So it seems like it was yesterday. Things that I think were yesterday were actually years ago at this point, and that's kind of scary. Nothing makes you feel less sane than having that experience. But the idea is that as your frame rate drops because your hardware is busy doing other things, rather than having stuttering in your game, you would dynamically reduce the resolution that is being drawn at, and therefore you wouldn't need as much resource in order to draw the scene, which it keeps frame rates high, basically. Yeah.
Is it like one of those moments in games where it's like, for some reason, for a brief second, all the graphics just suddenly become like very low quality, barely pixelated, or just
Potentially.
extremely muddied?
Yeah.
basically? Okay, it's like
Yeah, so either that's a load, if it's loading it in for the first time, it might load it in at low resolution and then high resolution. So that it either could be a load, or if it's something that's already rendered and then it swaps between different rendering details, that's usually to keep the frame rate the same. So if you're targeting 60 frames per second and I'm playing Path of Exile, and suddenly there are a million effects on the screen all at once, all of which require my GPU to draw them, my CPU to calculate whether they were hits or not. All of that going on is going to reduce my frames maybe down to 10 FPS, rather than suddenly have a stuttering game that feels like I can't control it. It would be easier to cut the resolution so that things look a little bit blockier, but it still feels like it's happening at 60 frames per second. That's a trade-off that you have to make. The level of detail of the scene is being drawn at versus the target frames per second. You can trade that off in a different way, reduce the resolution a little bit, deal with some frame drops. But again, that's up to how your system handles that. Frequently, you want to put that behind options to allow the player to decide whether they would like to drop frames or whether they would like to drop detail. But the way you're going to implement that is with dynamic resolution scaling and allowing that to be a part of your game. You could also just pop up an error message that says, get better GPU. Cheap gamer.
Imagine that being like, I don't know why, now I'm just imagining that being like a weird ARG thing where it's like only computers with this bad hardware can enter this area because the computer can't load it in time.
Yeah.
I love that you made a joke about that, but the CEO for the company for Lance 4 actually like said something along those lines.
Yeah.
Oh yeah, it's like, oh yeah, they didn't say like, oh yeah, didn't he say something where it's like, oh yeah, I don't know, get a better, I don't know, you'll pay for it or something like that.
Yeah.
Like you can't play this game, get a better GPU.
Yeah.
Or
Yeah. I like making fun of that indirectly because, of course, if you could do that, you would. Or if you cared enough to do that, you would. So nothing shows that you are you're distancing yourself from your consumer than with statements like that. So that's dynamic resolution scaling. Any questions on that? We can, again, take a look at the Unity documentation for that to show kind of what that looks like from an API perspective. So there's an entire landing page for this because you can learn about it, you can control how it scales, control when it happens, enable or disable for each different render target. So what dynamically scales, it doesn't have to be the entire resolution. You're not changing the actual entire resolution. You can just be changing the resolution of target assets that cause the most load and or are the least noticeable from the player's perspective. If there are a million skills going off at the same time, do I need to render every single one of them in great detail? Does the player actually notice all of that happening at the same time? Whereas they would notice if their player character were to be rendered in less detail, or the scenery were to be rendered in less detail. You could choose to render just the skills and the skill effects in less detail. So you have total control over what gets scaled and by how much based on how throttled your hardware is. So there's a lot of resources, again, on Unity's documentation to help you to be able to incorporate that into your game. In case it wasn't clear before, I do not expect any of these to be done in this game. This is outside of the scope of a 4-week game. Focus on other things. That said, these are useful tools for industry scale games, even indie industry scale games. Fixed time step calculations, this is probably something that most of you have seen and or may be using. So when the update gets called, the physics update, that happens very, very, very frequently. So it might be worth considering when do those updates, or what should I be tying those updates to? As your frame rate changes, it's very strange if the physics calculations don't line up with the frame rates. That can cause objects to seem like they're stuttering or teleporting, or it looks very strange. So if you use a fixed time step, independent of frame rate variations, then you get what is consistent physics, consistent logical calculations. So in Unity, you can just change the fixed time step by going into your project settings and into time. And then you change how frequently your time steps are being updated.
So,
Yeah.
Is this the kind of thing where it's like if you like this, everything, so time step is like to keep everything consistent. Is this the kind of thing where it's like, if you look down in a game, you for some odd reason move a lot faster than you normally should, and that's because the game isn't loading everything or something like that?
It's redrawing the scene every once in a while.
Okay.
That's based on the actual frame rate is what gets displayed, but the actual logical calculations that are happening underneath the hood and the actual physics calculations for what speed is this object going at? Did a collision happen? Those kinds of calculations are happening based on this time step. So if you make this time step very short, then that's going to be increased load on the physics calculation. So it's all of these are CPU updates for the most part. It has nothing to do with how frequently they're drawn, but how frequently they're updated and calculated. Any other questions on that? Nothing sucks more than having something change your frame rate at 10 frames per second, but because collisions aren't detected as frequently, then you end up with overlapping objects because it didn't check for the collision until after it had already collided. So you get clipping, you get very strange interactions. A lot of that comes from stuff like this. Yeah.
Are we wanting to dynamically change the time step?
No, you want to create it, you want to hard code it, because by default, it happens based on the frame rate, so that it's not calculating physics calculations more frequently than you can notice them. But sometimes, frequently, it's worth doing that. It's worth making sure that the physics are consistently being calculated, that the logical, any logical interaction is being calculated at that target rate. But there are performance implications for that. And it will do things like change the requirements, the hardware specifications that you need for your game because of what's happening underneath the hood.
But basically, you're decoupling it.
Yeah. So just another thing to be aware of. We can profile a lot more than just memory. We can also profile our CPU and GPU usage. This is a little bit less useful in one sense because every machine has memory, but different machines will have different CPUs and GPUs. So whatever you use to profile your usage may change based on target architecture, based on there's a lot more going on with CPU and GPU profiling. But this will help you figure out how many calculations becomes the bottleneck. If you have a CPU that can't handle this many calculations or a GPU that can't draw this fast enough, what are the actual bottlenecks based on profiling how much of your CPU and how much of your GPU are you using at different parts of your game? What is standard gameplay for your game? I'll go back to using Path of Exile as an example because I know it so well. But when there are lots of effects going on, as the game has become and evolved, it's now what, 15 years old, 16 years old? It feels very different to play now than it did 16 years ago. So any design decisions that were made a long time ago about how your CPU and GPU usage, what those bottlenecks are, that's changed because there are more and different skills. There are more effects happening at the same time, so that's changed. We should go back and do a new usage profiling to change the system requirements for the game. This also helps you if you've coded things such that the GPU is doing 90% of the work and the CPU is not doing very much. You may be able to determine or ask what of what we're asking the GPU to do could be done on the CPU instead. Even if it's less efficient, there's so much idle time on the CPU and so much bottleneck on the GPU that it might be worth trying to offload some of those calculations to the less used processor. Next, we have shader optimization. So shaders are used to do all sorts of graphics calculations, but sometimes you've coded it in such a way that there are more calculations happening than are necessary, or even there are some calculations that are necessary but can be approximated in a way that doesn't necessarily affect how the game feels to play from the player's perspective. So can we reduce the shading complexity? Can we simplify the calculations in a way that the player doesn't notice? Can we use more efficient algorithms that have better runtime guarantees? Since shaders are one of the main reasons that games end up not optimized, if you've ever noticed a game that doesn't actually look like there's that much going on, but still stutters, still has problems on better hardware, one reason for that might be the shader optimization. So if you're using more efficient algorithms, then less power is consumed, which is important if certain hardware is becoming overheated. You may actually be reducing the heat requirements, and anything that uses less power is going to be good. That means that you can reduce your hardware requirements or not be the game that is responsible for frying someone's GPU. In general, just less memory consumption. Faster GPU processing means that you can throw more at your GPU without bottlenecking it. So we get we can actually look at the shader performance part of the documentation. So here's a landing page again for shader performance. So look up textures instead of resource intensive functions. So just again, some ideas. Repeated calculations. In algorithms, we talk about dynamic programming. This is a very similar idea in terms of drawing shaders and using shaders to shade your assets. So make sure that you cache or use existing calculations so that you don't have to recalculate them. Lower precision data types if the level of precision is not necessary. So instead of a double, use a float. Instead of a float, use a half. If you don't need that level of precision in your variables. And that means that even though you're saving a little bit of storage space, it's not about the memory of that object. It's about how complex the calculations that you're requesting that object to do are. Think of long division with a double. There are twice as many digits, twice as much work to do to divide that as if you're using a float. And again, twice as much if you're using a half. So with less, you trade off the precision that the player might or might not notice for optimization. Another example of if the GPU is actually converting values to floats and back, then that is extra work to do. So know how the GPU is calculating it and try to use that instead. Other resource intensive methods for you to be aware of, things like the discard method, color mask, these kinds of things are what I'm looking for. They're resource intensive to just use in general. So try to use something that is less resource intensive. Just because a tool exists doesn't mean that it's the tool that you should use. You can prioritize lower quality shaders with the LOD command. So lots you can read. Here's the LOD directive reference. There's lots, again, big rabbit hole that you can dive into here. Now, the last one we'll talk about is multi-threading, because multi-threading is always something that's useful to do. Rather than having a single thread handling your game logic, whatever can be parallelized should be parallelized. You don't know the CPU that your end user is using. So rather than deciding on an amount of parallelization, you can create different threads. And then from those threads, you can query, is there enough on the CPU to be able to do that? Are there enough cores to handle that level of threaded logic? And then let the CPU handle that as long as you deal with the associated scheduling. So of course, if you're using more CPU cores, you'll improve performance. And this allows you to scale the game's complexity, of course, because the limit is just how much the CPU can calculate on a second-by-second basis. If you're using more cores of a CPU, you can ask the game to do more without there being a bottleneck of waiting for an answer to come back to you. So we can look at the Unity job system, since that's how that's handled. You'll create jobs and then allow the CPU to distribute those jobs. So if you use the job system rather than assuming that a single core is going to work and happen for all of your game, then you get frame rate increases, which is good. A lot of this is something that I don't have a ton of experience with, so it's probably why it seems a little bit on the vaguer side, and I'm using this as a, here, go look at these things. Again, they're tools that you should be aware of and not something that I can give you a ton of advice on. But a good rabbit hole to dive into. I revealed this slide very early based on a good question about what tools can we use for these things. So in addition to Unity documentation being a good resource for handling all of these optimization concepts, there are existing profiling tools for cache utilization, for dependency management. As your games start to scale in size, another reason I like the small 4-week game is you can keep the games reasonably small in scope and in size, but as you go out and make larger games for yourself, for money, then you'll need to scale your tool usage as well to be able to handle the increase in complexity of everything. The files and file dependencies, what you're asking the CPU or GPU to do. And that's another reason that we use Unity and not Unreal, is that it's very easy, especially in Unreal, to ask your computer to do more than it's capable of without significant optimization. But as you start thinking about using an engine that supports prettier and prettier, I don't know what the word I want to use there is. It's not the assets, but just the fact that Unreal uses C++. C++ is significantly more efficient in general than C#, especially than Java. You're able to do a lot more, but even then, there is significant stuttering with a lot of Unreal projects just due to the fact that you need to optimize. But boy, does that ray tracing look gorgeous.
I just wanna say, can we get over, I can't get over the fact that we went from like, this is RTX to now where it's like, this is what, like, we went from, that's what RTX looks like to whatever slop AI thing is with the NVIDIA.
Yeah, I've gone so far backwards.
Yeah, it's like, this is like, wow, this is really impressive. This is what it looks like, it's realistic to, this is what it looks like if it was garbage.
That's a great way to put that. Yeah, AI is not doing much for us right now. In general, the people who know how to use it, great. That's basically what I have prepared. Does anyone have any further curiosities or like, where would we extend from here based on your interests?
Well, okay, sorry.
Let's start with Adam.
Well, I was just gonna say on the topic of AI, isn't there like pretty big resistance in like game development communities where it's like I think you're not
Yeah.
allowed to win awards if you use AI in your
Yeah, there's still
I know that.
I'm basing this off very little information myself,
Sure,
but just
yeah.
recognizing that there needs to be to publish on Steam, there needs to be an AI disclosure of what you used AI for, so that it's not just that you can vibe code your way into a game, not knowing anything about coding, not knowing anything about game design, and launch it on Steam.
It does seem because like what was that thing like the video game crash like because like you know platforms weren't screening the quality of games that were coming in and that was like
Yeah.
Nintendo's big thing. They're not gonna like let you become a developer unless you were like vetted in some way.
Yeah.
It does seem like there could be like a new video game crash of some kind, you know what I mean, where it's just like
Yeah, that's
so much trash.
GTA 6 is gonna be the arbiter for that.
We've mostly stopped it, but when even 10, 15 years ago, there was a lot of slop being created, and the reason for that slop was Steam's trading card system, because you could create a game and then throw it in a dollar bundle. There used to be, 24, 30 game bundles for $1.
Mhm.
And why would you most of those games would be completely unplayable. You look at any reviews, they're all negative. But for a $1 bundle, you could get games that dropped 3-cent cards. You'd get 5 3-cent cards from each of 30 games, and that paid for more than the cost of the bundle in Steam Wallet. This is what I did. I used scripts to buy those games, farm those cards without my having to even download them or play them. Then you would script those cards to sell list in bulk at the market rate, and you could quadruple, quintuple the money that you spent in terms of Steam Wallet.
Hmm.
And then when deep discounts happened, you could actually buy the games you were interested in with the Steam Wallet that you got. And this is why I have 6,000 games on Steam and have not played anywhere near 6,000 games. Is a lot of it is just, the term is shovelware. It's made in order to have a bunch of games in your it's like shoveling dirt. No one wants the dirt. You just move it into your library so that you can, I don't know. They were garbage games. A lot of my library, I have an entire section dedicated, I call it ZZZZZZZ, games I will never look at again because they don't interest me. I don't want to play them, but they've done their task of getting me enough Steam Wallet. Steam's response to this, it took them years to implement it, but now you have to manually on the app list every single card. There's no way to script around that I'm aware of. There might be still, but now I have thousands of trading cards sitting around in my Steam inventory that I'm not going to spend the time to list and then list for 3 cents per tap. Like that's lower than minimum wage labor at that point. Might as well do something useful and productive rather than. Yeah. So they did a good job of taking that out of the system, and there were fewer and fewer shovelware games. Even though there were more and more games being released on Steam, the proportion of them that were reasonable quality increased, I believe, in the last 10 years. But now with AI, we're seeing that we've reached a peak there, and we're seeing more and more junk. But it's AI junk because it doesn't take very much developer involvement to make an AI slop game that you can then It didn't take you more than a few hours to make, and then you can add it in a dollar bundle, and the game doesn't make very much, but hey, you bundle it with a few other games that people actually want, and then you get a portion of the proceeds of that bundle. That's the entire purpose of the game's existence. It was never meant to sell for its MSRP or what it's actually selling for on the Steam store.
Yeah, this is kind of a tangent, but you ever see, like Steam credit only allows you to like buy GameStop. That's what like you trade for, like when you trade CS:GO skins, right? You get Steam credit or anything. I don't know why, but I just find it really funny that like these aren't real money, so it's kind of okay to be treated in the trade market, even though like you can buy a Steam Deck with that kind of credit, right?
Yeah.
So it's kind of, I don't know, it's just kind of funny. Like, this is technically like, I don't know if I want to say gamble. This is like the infinite money glitch. It's just you can buy like something tangible. It's not just games. You can buy an actual technically competent computer device through this.
Yeah. Yeah, it's especially bad if they have that same system now. I would be raking in the dough, buying Steam decks with it, and then flipping those for real money. And then it's not game credit that I am farming, it's actual money. And that would certainly be against what Steam wants to have in their terms of service.
Yeah. I just want to say real quick,
Yeah.
I'd be interested in like in the little time we have, like potentially like game theory kind of stuff. Like, how do you encourage players to do X or to think that do this thing or do something specific?
Okay, yeah, that is a very interesting idea. We could certainly at least start a discussion on that. So what's an example of something that you'd like a player to do in a game?
To think.
To think in the game, make an informed decision.
Yeah. Like I'll admit, when I think about making a game, there's always this feel of like I want the player to actually make an informed decision and not just be like, and hopefully not just be like, I have zero clue what the hell I'm doing, or I don't know. It's like,
Yeah,
it's hard to say. It's just like
real consequences are your best friend there.
Yeah.
I would narrow it down in like old games like point click adventures where you're supposed to solve a puzzle with like, what would I really do in this situation? You know what I'm saying? Like those, what's that thing? It's like something Monkey Island or something like that.
Yeah.
Like those kinds of games.
Secret of Monkey
Where
Island.
it's got like an absurd puzzle that you're supposed to do with point and click. Like, how do you lead people on that?
Yeah.
Maybe that's too hard of a question.
No, it's you either need to make them feel like their actions are tied to the game world in a way that has real consequences. So you have to get them emotionally engaged with the game world. Older games didn't necessarily have to do that because there weren't as many games vying for your attention. In the modern age, I feel like there's always the next game to play. And that creates significant developer pressure to keep people playing your game. And maybe that's a bit of what Simon wants or was thinking about with regards to that, because
if there's one game that sort of like fascinates me a lot when it comes to like game theory such, it's like it's gonna be a bit weird. Like there's a game called Fear and Hunger where it's like it fascinates me to think like the game is brutal and unforgiving, and it kind of interests me to think like what encourages a player to like I don't know about I guess not just invest time into it, but also like figure out the mechanics that are not even communicated to you or something like that. Of what makes the player realize, oh, I can do this to circumvent this issue, or I can, like I can do this to circumvent this issue, which can then help me in future runs, or like, or
you can use literary techniques. So something like foreshadowing, where in the dialogue, the characters are talking about how the world works, what options there are. And if the dialogue says that this is part of the game world, then the player will think, well, if it's part of the game world, can I interact with it in some capacity? For decisions themselves, you want to make the player feel like there's something at stake. There's a reason why this decision is important to make. There's a reason why I should be exploring and not just embedded in the tutorial. Have a smaller version of this in the tutorial that is walked through so that you show the player there are secrets. There is a reason to look around you. The puzzle at the end of the tutorial isn't possible to complete unless you internalized all the information from all of the components of the tutorial. And there are hints as to maybe go back and read or do a part of the tutorial again if you're stuck on this step. So it all has to do with world building, with motivating the player through the setting, creating meaningful decisions, and then have rewarding payoff to making those decisions. They should feel like they feel good about the decisions that they made, or bad about the decisions that they made. Like there are real consequences to their actions.
Thinking of
Games that I find that are boring are ones that don't do that
you don't. Message.
in one of those different dimensions, one or more of those dimensions.
Get the real ending. Yeah.
So they rely on skills that aren't just computer science skills. They're skills that you would get in other fields or other classes. So if you want to design a game with a motivating and engaging setting, try just writing a short story that takes place in that setting.
Right.
Then you can incorporate elements from that short story into the game that you make. You don't have to go publish that short story, but get those creative writing juices flowing and build up. You as the developer should know the setting and the world intimately. It's not just the setting that's surrounding the game. It should be a living, breathing world that the game takes place in. What's happening? What's at stake? Who are these characters? How do they interact with what's happening outside of what the player is doing in the game? Breaking the fourth wall of a game is recognizing that you're not in a game world. The game world ends right where the game is. Like imagine, I don't know, Final Fantasy 13 is a very linear game from start to finish. The game is only going to be as good as what feels like is happening beyond that linear engagement. Are there other characters who are living daily lives? Is the culture evolving? Is there a government? What is happening beyond what the player character is looking at? If the developers aren't thinking about that level of detail, then it's very easy to look just beyond where the camera is and recognize there's nothing designed out there in that space. And that's not very immersive. Any other thoughts or interesting directions people would like to take the last 5 or so minutes of class?
If we're gonna be shopping around for like better engines, are there things for us to keep in mind when we're looking for different, like, where to start with engines? Like,
Yeah,
how would I start my research to be like, I want to build this kind of game, which engine has the best tools for this?
that's a great question. I think it depends a lot on really the level of efficiency that's needed in order to do technically what you want to do. So I would start with what are going to be the technological bottlenecks? What level of detail are you going for? Are you going to be incorporating things like ray tracing? How complex and state of the art do you want your graphics to be? And then you will look at, well, what engines support what? So Unreal has the most potential for beautiful looking games. If that's something that you care about and want to design around, that becomes the right choice. If you want to, there's also a component of how much money you're planning to make off of the game. Like Godot is completely open source. You will see every single penny, no matter how much your game makes. Whereas Unreal and Unity start to kick in royalties at different levels. So as your game could potentially scale, what are you okay with there? Really, it boils down to what level of support exists out there. So there is certainly some research that you should do ahead of selecting what engine you're going to interface with your game, but That is a good question. Any others?
Or one, yeah. I know what else.
I guess we can call class a few minutes early if we want to.
Yeah.
If you think of anything between today and tomorrow, tomorrow is kind of the last day before next week. So I anticipate it mostly being a work day, but if anyone wants to bring in any discussion items or talk about how you would like to use the material from this class to either go out and design games, how to scale these ideas into something that start to make you some money, something to do on the side, or to turn this into a career, all of those would be interesting questions to explore. As long as it doesn't rely on any real-time research. Good. Sounds good. I'll see you all tomorrow. Sounds like there might still be food downstairs.
Oh, yeah.